Hello. In this video, we are going to learn about factoring quadratic functions. First, what is a quadratic function? The standard form is f of x equals ax squared plus bx plus c, where a, b, and c are simply numbers. It's a polynomial function of degree 2, meaning the highest power is going to be 2. It's going to have two solutions. It may have two real solutions, two imaginary solutions, or one real that has a multiplicity of 2. The shape of the graph is going to be a parabola. It has an axis of symmetry, and it has a vertex. The graph of y equals x squared looks like this. This is the most basic form of a quadratic function. Y equals x squared. The axis of symmetry is x equals 0. The vertex is 0, 0, and the root is x equals 0 with a multiplicity of 2. Let's look at the function x squared plus 3x plus 2 equals 0. The first thing we need to do is multiply our a and our c. Our a is directly in front of x squared. There's nothing there, so we understand it's a 1, and our c is 2. 1 times 2 is 2. So we need to find the factors of 2 that add to give us 3. 1 plus 2 equals 3. We're going to put both of these over ax. In this case, a is 1, so both of these go over 1x. We cannot simplify either of these fractions, 1 over 1x or 2 over 1x, so we're going to fill in our parentheses, bottoms up. So whatever's on the bottom goes up first into the parentheses. 1x and 1 and 1x and 2. Now, 1 and 2 are both positive. Therefore, a plus sign is going to go in front of 1, and a plus sign is going to go in front of 2. To finish solving, we need to set both equal to 0. We're going to subtract 1 from both sides. So x equals negative 1. And then x plus 2 equals 0. We're going to subtract 2 from both sides. So x equals negative 2. Those are our two solutions to this quadratic function. Before we can begin factoring every single time, our equation must equal 0. This one already equals 0. But if you have a function in the future that does not equal 0, make sure that you solve it for 0 before beginning the factoring process. Now there is a special scenario. We call it difference of squares. When you have something squared minus something else squared equals c, okay, this is going to always be a binomial, not a trinomial, so we'll only have 2 terms instead of 3. If you ever have 3 terms, it cannot be a difference of squares. If you ever see a quadratic that has 2 terms, this is something that you should be checking for as a difference of squares. So we're going to figure out what a and b are, and then we're going to use the formula a plus b times a minus b. Or in this case, I typed out a minus b times a plus b equals 0. So let's look at an example. 4x squared minus 25. So my first term is 4x squared. To determine what a is, I need to square root that. The square root of 4 is 2, and the square root of x squared is x. So my a is 2x. Then I see a 25. So I need to take the square root of 25 to determine b. The square root of 25 is 5. Now I know my a is 2x and my b is 5. So let's fill in our function. 2x minus 5 and 2x plus 5. A minus b times a plus b. But we need to solve. So we're going to take both and set them equal to 0. 2x minus 5 equals 0. We're going to add 5 to both sides. So we're going to get 2x equals 5. Then we're going to divide by 2 on both sides. So we're going to get x equals 5 halves. With 2x plus 5, I'm going to subtract 5 from both sides, giving me 2x equals negative 5. Dividing by 2 on both sides, I get x equals negative 5 halves. Those are my two solutions of this quadratic function, 4x squared minus 25. Let's look at an example. 6x squared plus 28x plus 16 equals 0. Whoa, baby, these are some big numbers. Well, let's look for a GCF. I have a 6, a 28, and a 16. What I notice about all 3 of these numbers is that they are each even. Therefore, I probably can factor out a 2. So I'm going to divide each one of these by 2. my 2 is going to go out front, and I'm going to rewrite this function as 6 divided by 2 is 3, 28 divided by 2 is 14, and 16 divided by 2 is 8. Now, we need to multiply our a times our c. A is 3 because it is in front of x squared, and c is our constant, which is 8, and that is 24. Let's list all factors of 24. We have 1 and 24, 2 and 12, 3 and 8, 4 and 6. I need 2 factors that add to give me positive 14. 1 and 24 equal 25, 2 and 12 equal 14, 3 and 8 equal 11, 4 and 6 equals 10. So I know that my 2 factors are going to be 2 and 12. So I need to take 2 and 12 and put them over my ax, which in this case is 3. 2 over 3x does not simplify. However, 12 over 3 does simplify. Dividing the top and the bottom by 3, I'm going to get 4 over x. To fill in my parentheses, I have to take my bottoms up first, which are going to be 3x and x, and then a 2 and a 12. Both of these are positive, therefore a plus sign goes in between. Setting both equal to 0, I'm going to take my final steps of solving this quadratic function. Subtracting 2 from both sides, I get 3x equals negative 2. And dividing by 3, I get x equals negative 2/3. Whoa, I'm running out of room. Let's rewrite that. Okay, there we go. Now, x plus 12 plus 4. Look, it's right there. What was I doing? I don't know. Well, I do know. I just don't know why I wrote that. So x plus 4 equals 0. I'm going to subtract 4 from both sides, and x is going to equal negative 4. So now I see that my 2 solutions to this quadratic equation are x equals negative 2/3 and x equals negative 4. Now in example 2, we're going to factor this quadratic function. I do not know why function is capitalized. Remember though, our equation must equal 0 before we begin. So to do that, first I'm going to switch to the pencil, but I'm going to add 4 to both sides. Now, 4 does not have an x with it. It's a plain constant, so I added it till its like term, which was 10. So 5x squared minus 17x plus 14 equals 0. Now, we need to say a times c. Our a is 5, our c is 14. 5 times 14 is 70. So we need to list our factors of 70. We need 2 factors that add to give us 17. Well, I could go through here and say 1 and 70, 2 and 35. I could keep going, but I'm going to go ahead and jump to 7, 10. I need 2 factors that add to give me negative 17. How about I say a negative 7 plus a negative 10? There we go, right there. Negative 7 plus negative 10. Now I need to take negative 7 and negative 10 and put them over ax. My a is 5. I cannot reduce negative 7 over 5x, but I can reduce negative 10 over 5x. Dividing the top and bottom by 5, I get negative 2 over x. Filling in my parentheses, bottoms up, 5x and 7, x and 2. Both the 7 and the 2 were negative, therefore minus signs go in front of them. I'm going to set each one equal to 0. I'm going to add 7 to both sides, so I get 5x equals 7. Dividing by 5, I'm going to get x equals 7/5. Then I'm going to add 2 to both sides, so x equals 2. And there are my 2 solutions to our quadratic function. That concludes this video on factoring.